So again you need to write na.
Okay, I have to write again. Only the CIG unallocated cell, you tell me. CIG unallocated.
So write the PQRD.
Just a minute. Just a minute. Just a minute. CIJ unallocated P Q R D
D.
A B C.
Sir, I'm telling row wise, huh?
Okay.
5 star, 4 star,
5 star, 4
4
star,
star, star 5 star 0,
star 5 star 0,
6 star,
6 star,
again star 0.
star 0. Now you find the numbers you want. What about the equation? Tell me. I'm writing the equations now directly. First of all, we have U1 plus
U1 plus V2.
Okay, U1 plus V2. What is the value?
3.
3.
Okay, then U1 plus
U1 plus V4.
what is the value?
0. 0.
Hmm.
U2 plus V1. 2. U2 plus V3. 1. U3 plus V2. 2. U3 plus V3. 3.
Okay, so how many equations we have got? 6 equations. How many variables we have got?
Sir,
Yes, tell me.
স্যার একটা জিনিস বলবেন এই স্যার ইউ1 স্যার কিভাবে এটা করছে তো বলবেন মানে
ও আচ্ছা বুঝতে পেরেছি বুঝতে পেরেছি
হ্যাঁ ওইটা ঠিক
ওকে ওকে জাস্ট এ মিনিট
হ্যাঁ স্যার
UI plus VJ, I stands for
কলাম না
row,
হ্যাঁ রো
J stands for column. Okay, so this is your first column, first row, second row, third row, first column, second column, third column, fourth column. So when I'm saying that U1 means the first column, first row, plus V2 means second column, first row, second column, first row, second column. Here it is, that means I'm talking about this first row, fourth column, row first, column 4. I'm talking about this. And only this is being made for allocated cells, not for unallocated cells.
মানে নন স্টার যেটা অনলি ফর দা অ্যালোকেটেড
স্টার্ট যেটা স্টার্ট আছে সেটা
ও আচ্ছা অনলি স্টার আচ্ছা
start unallocated cells. So number of variable here is 7, and number of equations here is 6. So independent choice is 1. Independent choice is 1. That is because 7 minus 6 equal to 1. So you tell me, any student.
So I can't get how we just get an independent choice because some network issue I was.
Oh, number of variable is
Can't
7. Actually, the rule is that if the number of variable is 7 and number of variable is n and number of equation is m, and if n greater than m, then n minus n variables is independent. That means you can put, that is, we can put 0 value to any one variable out of these n variables. So here I can put any 0 value to any one variable out of all these variables. Now you select a variable of your choice. Tell me, anybody.
U1 equals to 0.
Achha, U1 equal to 0. If U1 equal to 0, then your V2 is 3. You put U1 equal to 0 over here. This is my independent choice. This is my choice. So if I put E1 equal to 0, V2 equal to 3, E1 equal to 0, that is your V4 equal to 0. Next, you have got V2. So now V2 is here, V2 is there. So if you put V2 equal to 3 in this equation, so you will get U3 equal to 2 minus 3, that is minus 1. And now you have got U3, so you can put your value of U3 in this equation, minus 1, and your V3 will come as 3 plus 1, that is 4. And once you get your V3, that is 4, your U2 will come from this equation, your U2 will come 1 minus 4, that is minus 3. And once you got your U2, from this equation you get V1 equal to 5.
5.
Yeah, just check. Just check.
Sir,
Yes, sir.
I
These are coming.
don't get a point. Can I ask?
Yeah, sure, always.
Sir, just number of variable is 7 and number of equation is 6. So how we just find this number of variables equal to 7
See,
and number
in the section 1 of your syllabus, there is a chapter called linear programming problem. That chapter has not been discussed in details. Okay, but after transportation method, that chapter will be discussed. In that chapter, there is a theorem which goes like this. Whenever we solve an equation, a system of equation is having two things. One is the number of equation and another is called number of variables. Now, we are accustomed to a system where number of variable and number of equations are same. So when we get those two things same, number of variables and number of equations as same, so what we do, we get unique solution, and everybody knows it. We can use Sridhar Acharya method or cross multiplication method, and we can solve this system for same number of equations and variables. But
yes.
But if the number of variable is greater than the number of equation, then actually we cannot apply that Sridhar Acharya method or cross multiplication method. So the theorem goes like this: if the number of variable is n, and let me write somewhere, if the number of variable is n and number of equation is m, and if n greater than m, so n minus m, count it, find this value n minus m, and that amount, say this we can name it as v1. This number of items can have independent choice. You can put any value to this. Say for example, here n is 7 and m is 6. 7 minus 6 is 1. So out of these 7 variables, you can select any variable of your choice and you can put 0 for this particular variable. So I could select 1, I could select U1, or I could select V2, or I could select V3, or I could select V2, anything. But sometimes we have to make clever choices. So anyways, in the last class, I told you that I had to make the clever choice, but you don't have to think about the clever choices. If you, I'm telling all the participants who are present in my last class, in a particular problem, I told you that you have to make clever choices, but you don't have to do so if you remove the degeneracy from the picture. And you can make it in this manner, that always the number of independent variable will be 1. Okay, if it is in our present scenario, the number of allocations were 2 less than the number of required allocations. So we actually introduced 2 deltas to make the difference 1. So if you do so, then you don't have to make the clever choices by putting pressure in your mind. So the student who asked how did I get 7 minus 6 variable, that is one variable is having independent choice, and that variable is getting value 0. We are putting 0 over here, substituting intentionally, forcefully we are substituting 0. And that choice is actually helping us to find the values of the other variables. So one after another, substituting the value 0 here, first of all, we got V2. and then here after substituting here we got v4, then using that we have got the other value, other variables. So that is how we actually calculate. Okay, so now we are going to make another matrix, and that matrix is called the ui plus vj unallocated matrix. Ui plus vj unallocated matrix. Okay, let us find it out. So now I am going to calculate the ui plus vj unallocated matrix. Okay, so we are going to write p q r d a b and c, and the star part will remain same. The star part indicates that these cells were actually allocated from the beginning, so we shall not consider this is a rule actually. And we are going to put these numbers over here. We are going to put these numbers. So you see my this is ui, so my u1 equal to 0, my u2 is equal to -3, and my u3 is equal to -1 as I calculated. And my, sorry, just a minute, and my vj I'm going to write, so my v1, that is this one, my v1 in bracket I am writing, my v1 is how much, 5. My v2 is how much, it is 3, yeah. My v3 is 4, and my v4 is 0. Yeah, now I am going to use these numbers to calculate what the blank portions. So if I am going to calculate this, see, remember the equation, the students who are new, remember the equation is ui plus vj equal to cij. So cij represents cost. Okay, so if I add u1 plus v1, you are going to get the cost in the cell C11, in the cell 11. So here I'm going to calculate the cost. So I need to, if I use this formula, I need to add the numbers u1 and v1. So u1 is 0 and v1 is 5. So I am putting 5 over here. For this, I need to add this cell is what cell? First row and third column. So for first row, tell me.
So there's no negative value, so the TC is minimal.
Then we are very much, myself and you are fortunate enough that negative numbers are not coming. And I'm going to say you something. Don't you just point me out if I miss that. Anyways, let me finish it. So 0 plus 4, that is 4. Okay, and this for this we actually add these two, 3 and -3. And for this we are going to get -3, and here I am going to get 4, and here -1. And now lastly, since few students are there, yeah, since few students are there who are very new to this, because they are also took late admission, so therefore they are actually having some troubles. So lastly, let me wrap up this particular problem. So my ultimately what we get, we have to calculate, ultimately we have to calculate this matrix delta ij. So delta ij, the definition is delta ij unallocated. The definition is you subtract ui plus vj unallocated from cij unallocated. You have to subtract this matrix from this one. So we are going to write p, q, r, d and a, b, c. And you see, if I do so, 5 minus 5, that becomes 0. Star will remain star, no problem, because we are not actually considering them. 4 minus 4, that is 0. And that is star. Okay, last we get star minus star, that is star. and we get
5
5 minus 0, that is 5, and we get
star
start,
3
yeah, and we get 0
3
minus minus 3. Remember, 0 minus minus 3, that is plus 3. So the last cell is plus 3, and this is 6 minus 4,
2
2. This is start, this
star
is start,
star 1.
and that is again 0 minus minus 1, that is 1. So the theorem goes like this: if all the elements, if all elements of delta ij matrix are non-negative, we can say that TC is minimal. So the TC which you have got here, that is rupees 50, is an optimal, that is minimal transportation cost. Now I am going to make a few points which is very essential. The point is that let me write the properties of deltas once again, because this delta section is new, properties of delta. Today I am, by this lecture I am going to wrap up my transportation class, class on transportation problem. Later if required we will again discuss transportation problem. Properties of delta, let me write it: Cij into delta equal to 0, Xij plus minus delta is equal to Xij, and delta plus delta equal to, yeah, delta, and delta minus delta equal to 0. Now you see, during the Modi method, point number 1, during this Modi method, we actually have used property 1, actually property 1, but we have not used these 3 properties. These 3 properties will come into the picture, when we go for method of looping. What is method of looping has already been discussed in the last class. Since the scenario has not appeared in my today's problem, so I have not discussed it. The students who are new to my today's class, so please go, I am referring them to my earlier videos, and go there and see what method of looping is. You will understand. Now I am going to give you a scenario, a simple scenario. Suppose for example, we have a matrix like this, say A, B, and C, D. This is my matrix, and we have got a loop like this. Suppose this is my loop. I have got a loop like this. Okay, and suppose we know that after putting the loop, we have to alternately plus add some allocation, and alternately minus some allocations from the corner points. Okay, we do it because I'm just referring to my previous video. Just go there and you'll find it. So if this is my starting point and this is my direction of the movement, so we allocate plus epsilon over here and then minus epsilon. Suppose the allocation during the method of looping, this cell was allocated with allocation delta, then I have to write delta minus epsilon. Okay, and suppose this allocation was say delta prime, then I have to write delta prime plus epsilon. And suppose this is my say 5, then I have to write 5 minus epsilon. And then what we do, we consider this equation minimum.
Sir.
Of, yeah, tell me.
So sorry to interrupt you, but we have a seminar from 5.
Okay, I'm just going to wrap up right now. I'm almost done. So just last one point, that if I equate this minimum delta minus epsilon and 5 minus epsilon, equate it to 0, we actually get, we have to select between these two, delta minus epsilon and 5 minus epsilon. But delta is an abstract quantity. So obviously you cannot, if you say that delta minus epsilon is the minimum, if you say so, okay, So what will we get? We will get epsilon equal to delta. So that doesn't have any meaning. Okay, just 1 minute, one more minute, because if I leave you at this point, you will not understand. So we will not go by this. We'll avoid it. So if delta is involved, so the minimum will always be the thing with the number. So the minimum will be 5 minus epsilon, which will be equated to 0, which implies epsilon equal to 5. Now epsilon has come out to be 5. After this, what we do? We put the value of epsilon over here. So we'll put 5, and here we'll put delta minus 5, and here we'll put delta prime plus 5, and here we'll put 5 minus 5. And then we can apply these properties. You see, delta prime plus 5, 5 plus delta prime, 5 plus delta, 5 is the allocation, 5 plus delta prime is 5. So this value will be 5. Minus 5 plus delta, this plus delta, minus 5 plus delta will be minus 5. 5 minus 5 will be 0. And like this. So since we have not done the method of looping, these properties were not actually used. So I shall, before I complete my today's class, I must say that before you go for applying the Modi method, you always try to make your degeneracy, try to remove the degeneracy, make the solution matrix non-degenerate, and then apply Modi method. Then the troubles will not appear. The troubles which we actually faced will not come into a picture. So with this, since we have seminar, with this I'm going to wrap up my today's session. Best of luck. Tomorrow you are going to get your assignment. Accordingly you do. And on Sunday at 5 p.m. I'm going to take the examination. So I'm going to end my today's session. Bye. Bye for now.
Thank you, sir. Bye.
Bye.